Hello everyone. Um, well, this video is technically and basically how to summarize 1 hour plus medicine lectures in a way that we med students can make use of, because there are a lot of ways of summarizing things, and some other ways are not GPT related, but this one it is. It uses the GPT-3 API call. I know there is already the Chat GPT API, and since that's another large language model and it's also cheaper, it could be better, the performance with that language model. But I built and I prompt engineered this one into GPT-3. So later on, when I have time, I will be building this project upside down, from scratch with the ChatGPT API because it's cheaper and that's better overall. So yeah, right now I am uploading it as a Google Colab notebook. Google Colab is just a format of Jupyter Notebook, and you can look down from in Google and YouTube in order to understand what is a Jupyter Colab format. But yeah, technically, code is just language that computers understand, and I am explaining this because my target audience is mainly medicine students that are looking for ways to actually be faster on their learning process. So yeah, how do I do it? Well, you have to know that GPT-3's max request in terms of size is measured in tokens, not in words. And for each API call you do, you can't surpass 4096 tokens. Therefore, medicine lectures that are an hour plus long, they will surely pass that cap limit. They will surely be more than 4096 tokens or more than 50,000. I've had medicine lectures that are like 50k tokens in total, something like 60k words. So yeah, this is something will that I have been using in the last months. I assist to the classes, but I just don't study them the way I did with the books and all that stuff. I just go directly to the summarized transcription of what the teacher, in my case doctors, say. So it's a more efficient way. It is not the best. The best is that you sit down, read the books, memorize all that stuff. But since we medicine students do not have time like to even spend with our family, so I came up with this idea. So I'm gonna show you guys how is it looking right now. You have to enter to Google Collaboratory. You can look it up on Google, and once you enter, you go in with your Google account, your main Google account, and you will be received with something like this. Not this exactly, because this is my copy of the program, and you have to know that it's built in Spanish, and there are some things you would need to change if you wanted to run with English. But I am making this video in English because I feel more comfortable explaining the code in English, and also I will hope that anyone that's a native English speaker and it's also a medicine student can make use of this. So Google Colab is what you're seeing right now. You have right here your folders, your explorer, your file explorer. It's right here. You have some folders and stuff, and if you go, that's the upload button. Sorry. You could go one folder up, and you have all these folders that I don't know uh, what are they. I know that this folder stores like the files that are imported once you install them with mainly pip. Pip is just a command or a package manager, because my program, it is not built from scratch. It uses others people libraries, right? um, so yeah, let's just go back to sample data. Was it content? It was content. All right. So you can see that I inside content I uploaded this file, this mp3 file. Don't worry about all this stuff. Once you have your file, you can just go around, select it, and just drag it here, no matter where you drag it, because you're going to be inside this folder right here. And I made the code to look in that folder, so don't worry about all these folders. You just have to know that once you drag and drop this here, or your mp3, your mp4 file, it's gonna be read by the program, because I program it to look into the content folder. So how does it work? Before I'm actually explaining how does it work, I also need to tell you that you need, once you want to run this code, you need to change the runtime to our runtime with hardware accelerator being this a GPU accelerator, because the transcription process needs GPU VRAM. So once that's said, you also have to know that I am not a programmer. I am somewhat below the junior programmer, and I did this with the limited knowledge I have. So first, we ask the user to input his or her key and the other pronouns. And yeah, so you first input your API key. How do you get your API key? You go to OpenAI API. All right, you enter to the first link. You right here, you will need to click on a button that says sign up. You create your account, give your number, give your email. You do all that stuff, and then once you have created it and also you have done your verification process, you get to here. This is like all the contents in order to know how to use the OpenAI API completion endpoint, but you don't have to do this. And it is not only the completion endpoint; you also have embeddings and all that advanced stuff. But yeah, this is what I ate for months, from morning to evening. So you don't have to read any of this. You just have to go right here in the top. You go to view API keys, and then you have to click right here on create new secret API key. You click there, and then you will copy the key that it's going to prompt you with a green button. Do not show your API key. So once you got your API key and you already uploaded your file into the content folder, then you're ready to run the code cell. Since this is oriented to my target audience, which is medicine students, I know that there are way better ways to do a Jupyter Notebook program and a demo, but since my target audience does not know any of programming, I did it in just one single code cell. So I start with installing all the necessary libraries and also creating this .env file that I don't actually use, but that's okay because this was something I did back when my project was local. But yeah, then I import all the necessary libraries. You can check which libraries I use. Then I define the functions. This function, in a nutshell, was initially in the local process, in the local repository, was the one that handled the files and also the API key of the user. But since I do not already know how to create a user interface, I just know that I can create it with TechInter and all that stuff. But I just uh, haven't the time to do it. So yeah, this is the file handler. It just looks inside the content. Well, right here creates a .env file to start the OpenAI API key. Um, right here retrieves, writes the OpenAI key that the user inputted, and then it goes around all the files inside the content directory and find the .txt files, which are going to be the output of the Whisper transcription process. Alright, so it will return a dictionary with the keys being the file names and the values being the contents of each file. So that's a pretty easy way to manage multiple files. I have the name and I have the content inside one single dictionary of all the files. I don't know if that's like memory friendly in terms of the computer science stuff and all that, but that's the way I found it to be easier. So that's the first function I defined. Then we have this splitter. The splitter just takes in a single string text and the chunk size I want to split such text. So I have this sub function. I don't know if I can call it that way. Um, Also, before I'm going to explain this splitter function, I really want to mention that I know that oriented that object-oriented programming exists, and I know that that will be probably a better way to do all this. But yeah, I know that this is just something basic. Just please take into account that. So yeah, the splitter defines a function. In the future will be a method once I do this with OOP. But yeah, I define another function that it is going to just split a list. This just splits a list, whatever the list is, into um, n number of elements. That's just what this do. All right. There are better ways of doing this, but whatever. Then I declare this variable into an object that's created by this class, the GPT-2 tokenizer fast, that inherits the attributes of this subclass. And I specify that I want to use the GPT-2 tokenizer, and I state up the verbose option to be false. Then I declare this function like to the output of such tokenizer, giving it the text, which are going to be the contents of the dictionary that I declared earlier, right? And I just specified that what I want to get out of the tokenizer are the input IDs, and I want to store them into this variable, which will be a list. So this is a list. This is just tokenized text. You know that computers do not understand words themselves. Well, they they understand numbers. So what these do is just actually it takes words and turn them into numbers, and it stores each word or each token inside this list. Then I use the subfunction I declared earlier to split that list of input IDs into the desired size. Sorry. Then I create another list in order to decode those numbers, because remember they are encoded, they are numbers. So if I use the decode method right here, the tokenizer.decode method, then I will decode them back into words. They are right here, they are numbers, and once I decode it, they are words again. And I return this splitted um, list of words, because I turn them into token spheres first in order to know where I will be splitting them, and then I just return the splitted text, and that's it. That's like the most complex function of all. The rest of the functions are just API calls to the GPT-3 completion endpoint. With these prompts, you can use these prompts whatever you like. You can use this code and sell it, whatever. First, the corrector function is just an API call that tells GPT-3 this instruction, which is this is a medical transcription. There are mistakes in it that need to be corrected word by word in Spanish. You can get rid of the in Spanish thing if you are using this in English. I created it in Spanish because my classes, my lectures, medicine lectures are mainly in Spanish. That's why. And then I input each chunk of text that was outputted from the previous splitter function. Then we will talk about the summarizer, and the summarizer is just another API call which has a different prompt, which is rewrite this. Let's think step by step in Spanish. Again, you can get rid of the in Spanish, and then you will end up with English results. And notice that I didn't tell it to summarize, because if you tell it to summarize text, it will over summarize. In terms of medicine, it will normally over summarize. You need all the details in medicine in order to do a good clinical practice. Also, I use this magical prompt that is, let's think step by step. Sorry, this prompt creates a way of communicating between you and the language model that follows something that's called thought of process. Thought of process is a prompt engineering technique that helps you and the language model get the best results of those requests you do to it. Next we go to the Yankee generator, which uses technically two things: one API call to the language model with this prompt, use questions and answers format, create Spanish Anki flashcards based on the following text, be extensive, and then I look into the responses of the API calls to find the answers and also the questions, and the answers I will save them into this answers list, and also I will save the questions into this questions list. Then I create the Anki deck, and then I assign each field of question one element of the question list. And for each field of the answers field, I assign each element of the answers list. So it is not that complicated. Then I just, well, you can see that right here is the for loop that just adds what's corresponding to each field of the deck, and then I just print the Anki package has been generated, and with the file name that I passed in right here, which was the key of the dictionary. That's the splitter return. No, it was not the splitter. It was the file handler and API key handler. So I have right here the document generator, which will use Python docs library. I know that I can generate PDFs, but the easiest way I found was to use the Python docs library. So yeah, I pass in three values: the summaries that were the responses of the GPT-3, the transcription list, which was well, it's a list because the summaries are two. These two are lists because that's the format that's going to be returned by the functions of the API calls above. And then I use the file name dictionary value, well, not value, the key that the dictionary at the beginning was established, right? So yeah, you can change all this. You can change the title of the document. You can change the titles, subtitles inside the document where you want to change this resume to summary, and then you would want to change this transcription into transcription. So yeah, this from here, the code itself is what really does the heavy lifting. All right. So first you get all the files inside the content folder. This will list your MP3 and MP4 and everything in there. Then we're going to change their names because we are using the names inside a command line, which was the Whisper command line for the transcription process. So we first edit the file names in your content folder, because if there's a white space in your file name, or if there is an accent like this one, like that one, you will end up with an error, because I know that command line, well, you should know that command lines are that delicate. If there is a white space, your command changes completely. So yeah, that's like the pre-processing of the file names. Then I go around and I filter which of those files are audio or video files. Once I filter that, I just, for each file inside the content folder, I run this command, which is the whisper command, that uses the large V2 model to transcribe in Spanish what was being said. This is important. You have to change this if you are using this in English. So First, I get the file contents dictionary with the function I declared above. This will return a dictionary with the keys as file names, or the file names as keys, and the file contents as values. So I iterate through that dictionary and assign this iterable variable the keys, and this one the values of the dictionary. So right here I have the file name, and right here I have the corresponding content of that file. So I look through each .txt files, which, as you can see, are the output of the Whisper transcription engine. Then I use the splitter to split into processable chunks of each file. Then I correct the chunks of text, because normally Whisper can give inaccurate transcriptions. So I use the corrector to correct those mistakes that Whisper do. Then I join that correct transcriptions, because I need to split them again, because this number can be changed. This number can range from 1750 to 2000 tokens, because the higher the number is, the shorter the summary will be. Actually, if you put 2000, you can end up with a summary that's 30% long of your transcription. And if you use 1750, you will end up with somewhat 56% of the original transcription in terms of length. So then I use the summarizator function, that is the function that we declared above. Then I summarize, and then inside the document generator, I pass in the summaries list, the corrected chunks list, because inside this document we'll have both. We'll have the summary and also the transcription, the corrected transcriptions inside it. Then I pass in the file names iterable variable, so we know how to call or how to name the document that we are generating. Then we are going to do technically the same with the Yankee generator. We pass in the summaries list and also the file names iterable variable to know how to call the API, sorry, the Yankee package, right? Then all this, it is just to filter what the docx files and what are Anki files, and then we just download them. and and yeah, so that's technically it. You can see that this is already running. You can see that, let's show you right here. This is all what you're going to see once you start the process. So yeah, right here, this was the transcription process. You can see that it has timestamps. So this is in Spanish, obviously, because that's how I study medicine. And you can see that the teacher is saying something here. Pues obviamente se toma la FSH, se regula el ciclo menstrual o se regula la TSH para que tenga ciclos menstruales y ovulados y ovulación. You can see that there is a mistake here. Maybe if you know Spanish, you can tell that there is a mistake. That's why I created, or I declared, the corrector function above. But yeah, that is the transcription process. It's pretty good. I believe that if it's good enough in Spanish, it will probably be somewhat perfect in English. So once the transcription is done, we start with the API calls. Then well, first I split the chunks. There are 12 chunks to be processed. Then I say it again, because I am calling the corrector function. So that's why I print here 12 chunks to be corrected. So it starts the correction. This is the transcription, and this is the corresponding correction of that transcription. Then again, I go to the second chunk of text, and this is the transcription, and this is the returning response, or the correction of it. And then I just repeat the process and repeat and repeat and repeat. And once I finished up with all the transcriptions and all the corrections, then I start summarizing. You can see that right here the print statements changed. You can see that this is the second time I split the text. Now there is 11, not 12 chunks to be summarized, and then I print here that actually I am using this summarizer function, then I just summarize. I tell it rewrite this step by step. So vamos a hablar sobre el tema de la infertilidad hoy. Es el último tema para el examen correspondiente a este parcial and all that stuff. So I will end up with summaries, and once it ends up summarizing, it will generate the document. So I'm gonna pause the video for you guys to see the results. I encourage you though to actually um, test it with your own virtual lectures. Note something: if your lecture is 30, well, less than 30 minutes long, you will have to change the second splitter value to somewhat like 300. Well, technically both values of the splitter, you will have to change them to 400 or 300. But if you are not processing something less than 30 minutes, just use the values that are default, that I left them there. I will upload this into GitHub so you can also collaborate on this. And yeah, that will be all. I'm gonna just stop the video real quick. So it's stopped. It's already done with all the processing. You can see right here that I am also printing in the terminal that these are the flashcards that were generated. Yeah. So this is the question: ¿a qué hora se administran pulsos de gonadotropinas para estimular el ciclo ovárico? Se administran pulsos a las 7 de la mañana. ¿De qué modo se programan los espermatozoides? Se programa mediante ultrasonido de un modo similar a una relación sexual, aunque sin sexo. If you know Spanish, you can tell that this does not make any sense at all, but sometimes do. And when it does, it works. So, and it will download automatically the files. Let's check just the file. It's this one. It's just a Word document. Then you end up with the summary. It's useful. Like, the summary is not that bad. Just a summary. Normally, the Yankee flashcards, those are bad. Those are not entirely useful at all. So, yeah, what is above here? Yeah, all that is the summary, and from here it starts just the transcription. So yeah, that's my project. Hope you guys can find it useful. I will still be updating that thing because it needs to be updated. It has to also have an UI and all that stuff, but I first need to understand how to actually do it. And I'm also trying to figure out how GitHub works. So yeah, that will be all. Thank you.